Hey, g'day, it's Prezzo here. Thanks for joining me for part 3 of the Mixie clock build. And today it's all about metal machining, and we're going to have a go at getting these castings prepared to go on the clock itself. First job is going to be to get on the lathe and do these end plates. These are going to need to be machined to diameter, which is going to be a little bit bigger than the timber frame of the clock. We also need to machine a flat surface here and drill a pattern of 8 holes in that. So we can fit some wood screws through to the wooden frame of the clock to hold these in place. A bit of cleaning up and a bit of tidying. We need to drill and tap a hole in the end lug here, but other than that it's just straightforward machining on the lathe. Now this casting here doesn't need much either. It's going to have a pair of 1/2-inch holes drilled through these lugs here. Now these are going to take some common or garden variety domestic copper water pipe, 1/2-inch diameter, and they're going to have a pair of T-fittings on top, and then copper tube is going to be fitted into that and bent up to make a sort of a support arm for the rest of the clock. Now having the tube is important because we're going to run a wire up the inside of that as well and up the arm, and that's to take the power from this 5-volt power supply socket. Now it's going to need to be fitted into the back of this casting here, and to do that we're going to have to machine a flat and drill a hole through so that when this goes in it's sitting on the flat and not on the curved surface of the casting. The only other thing that needs to be done, and I've already done it on this one, is to make the surface flat. So I just put this on my table saw on a big piece of flat emery cloth, and I'll just rub that backwards and forwards to give me a flat surface. So that's pretty much all we need to do with these. So let's head over to the lathe and have a go at these. First thing I've done with these castings is go around the edge there and just belt sand all of that to remove the worst of the flash and any protrusions and so on. And like all good YouTube machinists, I'm going to put this in my 4-jaw chuck and pretend to set it up. And then say, oh gee, look how close I got that. Yeah, it's all fake. Anyway, what I have done already is just gone around and just eyeballed that. Remember, it's a rough casting, it's not going to be perfect, so if we can get the run out on that to say 0.1 or 0.2 of a millimeter, that's good. Now the only areas that are left unmachined are these 2 curves here. Everything else is going to be cleaned up, so we really want those to be running fairly accurately. So let's have a quick look. That's not bad. So I'm going to machine up this boss here, and then we're going to center drill and drill that, get a thread in there. This is quite a fine thread. It's 3/8 by 32. It's a model engineer thread. I don't need to go all the way through with this. Probably about 1/2 inch is plenty. Alright, now I'm going to turn this around, grip this by that section I just turned, to clean up the rim and machine this face here, because the chuck jaws extend out past that surface there and it's got to be a bit thinner than that. So I've got an ER40 collet in the headstock spindle here, and we're just going to grip it by this little section here. Now that alone is not enough to hold it, but we're going to back it up with the tailstock and do a version of pressure turning to drive the part against the tool. As you tighten the collet, you've got to keep pressing it back against the face of the chuck. You can see that there's not a lot holding that. Just looking out the door there, because the Indian miners are going mental in the tree. There's probably a possum or something up in the tree there that they don't like. Can't quite see. So what I've got here is just a little aluminium nose piece that goes on the tailstock centre, and it's got a very thin rubber face on that, and it just conforms to that casting shape. Sorry, I'm just looking out the door there. There's cockatoos got in on the act now. There must be a goanna or something in the tree. Alright, so that's going to press that against the face of the collet chuck. And we just keep tightening the chuck and putting pressure on the tailstock. And then we're just eyeballing the run out on that surface there. It's pretty good. Now I can machine all the way along this face here. Luckily, probably bad casting technique, but there's a bit of shrinkage in the center of this casting, so as we machine that face, it sort of runs out into that depression there, so I don't need to machine all the way to the center. And don't forget, the end of the wooden clock frame is hollow anyway. No, that's not bad. I'll machine back the other way, and that'll give me a slightly better finish. Check that out. Now, any of you guys are still melting scrap in your home furnace, get yourself some good quality 601 ingots, and that's the sort of chip you're going to get off your finished castings. And before I switched to using virgin 601 alloy, I was just melting old cylinder heads and water pumps and whatnot, and it just came off like powder. It was gritty and grainy, it knocked the tools around, but this stuff's beautiful. So thanks, Martin. He's the one that turned me onto it. Alrighty, so I'm going to clean up the rim now. There are about 5.7 millimeters to go, and I'm not really working to super accurate dimensions on this. It just needs to fit the timber frame that I've already made, and it needs to be about 1 millimeter oversized, so the end caps are a little bit bigger. So what did I say, 5.69. So I'm just setting up the DRO for this. So that's our finished diameter, and what I need to do now is get this rim down to the correct thickness. Now all I'm doing is matching up with the other casting that I've already machined. So that one, so we're finishing at 4.5. I do about 3.5 millimeters to come off. These diamond tool holders come in both left and right, which makes it really super handy for doing the back side of this. I know you can't see that, but I'm just thinning down that rim there now. I've just turned the camera around the other side there so you can see what I'm doing. But we're just reducing this diameter here and then running it up against this face here. So this flat here is where we're going to have the round head wood screws to hold this onto the timber frame. Now it's got to tidy up this little step here now. So it's going to have just one more step in it, and then we'll clean up to this inside line here. Alright, so it's pretty right now. This is a bit ugly in here, but as you see later on, I can fix that. That's not a problem. So I'm just going to take the worst of the broken area out of that, but not, or try not to affect the surface finish of the casting. Alrighty, so I'll get some chamfers on that and we're done, at least on this section. And we're going to give it a sand, clean it all up. Alright, so I'm going to turn this around now and just give this sand with some emery, and then that one's done. Well, there's the back, not that anybody's ever going to see that. And here's the section we just cleaned up here. I'm just going to give that a rub with some coarse-ish sort of emery, just to take the worst of the sand texture off that. Alright, that one's finished. I know it looks ugly around here, but I've got a plan to fix that. When we're done, you won't even know. I've got to drill a pattern of 8 holes around each one of these cast discs, and these are to take some very small round-headed brass wood screws, and they're going to fit through those holes and then screw into the end of the wooden frame. So for me, the easiest way to do this is on the CNC mill. So I've just held down a piece of MDF and I bored like a large diameter hole just in case there was any of this casting protruding above that flat surface there. And I've got an aluminium stud that's super glued into that MDF. So you just drop each one of these down here and then hold it in place with an M6 cap head screw. And I'm going to go around and center drill first, just to be sure the drill bit doesn't flex. So we're just going to nip that down. Just need to make sure it's not going to spin, that's all. So center drill first. Now I never home my machine. Between operations I just simply set my Z height and then run the program. If I was doing fixtures and jigs, yeah, you could home the machine and then use offsets, but for me it just doesn't make sense. So I'm just going to use the pendant here. and then I usually just go the rest of the way with the quill, and then lock the quill and then set my Z height there, and then come back up again just in case anything funny happens. Okay. Okay, that was bad. Don't know if you noticed, but on one of those holes, this whole thing shifted a bit. Did I not tighten that properly? Alright, I may have to step this through one line at a time. So let's go back and we'll do our finish drill size. That's typical. I did 3 others and they were all perfect. The one I put on camera, I screw it up. Alright, I might as well drill this one while I'm here. Yeah, I'm not willing to risk it. I'm going to do these individually. So let's come up. I'm going to set my Z there. And I'm just going to run this through on single block mode. So it's going to be my first location. Yeah, it's sort of a tiny bit out, but I'll drill it anyway. Alright, that was so close. I could have run that using the program, but I just wanted to be sure. Alright, so they're all done. I'll deburr all those holes, and then we're going to move on to doing the cast base for the clock. So on this cast base here, we need to drill and ream 2 holes for this 1/2-inch copper water pipe. And just to ensure that we get a good start for the drill, I just lightly file that flat. And all we need to do here really is just center the drill holes on those cast features there. No precise measurement required. And we're going to drill a hole in one side here for the power supply socket, so we'll do that there. That'll make that the back of the base. Just while we're waiting for that to dry, this was the one that had the sort of the defect in the end of the casting here where there was a big lump of metal. I just filed that away and I filled some of the little hollows there with some metal epoxy, and we can powder coat over that and you won't even know it's there. So with these, we're just going to use the center square. It's close enough, and then when we start the drill, I'll start off with the pilot size and then we'll gradually open the hole up, and we'll just have to eyeball that and make sure the hole is forming concentric with that cast boss there. And if it's not right, we can adjust it. Alrighty, so we'll go ahead and pilot drill those holes now. So this is a 12.6mm drill, and we're just going to get the hole started. Now that I've started that drill bit there, I can check to see if those countersinks formed by the drill tip are concentric or roughly concentric with that cast feature. Now if they're not, you can draw the drill bit over one side by filing the pilot hole slightly oval in shape toward the side that you want the bigger diameter drill to go. So let me check these. If they're okay, we'll keep going. If not, I'll adjust them. So both of those did need adjusting a bit. This one I pulled toward the left hand end, and this one also toward the outside end, the right hand end, and a little bit toward the sort of like the what's that, about 4 o'clock position. So I'll go ahead now and drill them a bit further and just see if that corrects it. Now I'm going to ream these holes with a tapered hand reamer, and we're not going to go all the way through because I want the copper pipe to jam in there, so it's not going to drop all the way to the inside of the base. That's sort of how we want that, so that's probably going in about 1/4 inch, 6mm, and then it's jamming up, which is good. Now I've got to drill an 8mm hole for this little power socket here, and it needs to go in the center of the length of the casting, and I'm just going to set this out with one of these little scribing gauges. And the easiest way to do this is just guess. Scribe a mark from one end, do the same from the other end, and you're going to get, unless you're very lucky, you're going to get 2 lines, and then you just simply split the difference between the two. And you might need to do that a couple of times. That's pretty good. So we'll go ahead now and put a scribe mark a bit closer to the base. Exact distance up from the bottom of the base isn't important, but we're going to need to be able to drill that hole at a tangent to the curved surface there. So it's going to be on an angle, some undefined angle. I think I'm going to have to set this up and just eyeball it, and then when we're happy with it, we'll drill right through and then spot face on the outside. Now this is one of those jobs where you say, how hard can it be really? We're just going to drill a hole through here. It needs to be 8mm in diameter for this little power socket, and we need to have a flat surface for that nut to bear down onto when we tighten it up. And because of the positioning and the shape of the casting, I really have to go in with the spindle of the Bridgeport set up so it's more or less normal to that curved surface. So normal means that the spindle axis intersects the center of this curved surface here. Now, in order to check that, I'll just put a hex-headed bolt in there, and I've lowered that down onto that curved surface, and I've just eyeballed it. So if you get a torch or a light source and just check it underneath the head there, you can see whether you've got it more or less tangent to that surface. So I'm going to go ahead and drill that, and then we're going to counterbore. Now, I've got an 8mm spot facing tool. Now the pilot diameter on that is about 8.2mm. We got an 8mm thread on the power socket. So after I've drilled and spot faced, we've still got a curved surface on the inside there. I'm hoping I can get that spot facing tool through from the back and clean that up as well. If I can't, doesn't really matter. That's still going to tighten down okay on the outside. So let's go ahead and get that hole drilled, and then we'll do the spot face. Okay, well let's hope we got that right, because it's going to be really hard to set that up again if it's not right. Okay, well there's that fitted there now. I don't think it's necessary to do anything on the inside of that. That's quite firm. It's not going to distort. It doesn't need to be overly tight, so I think we're pretty good there. Alrighty, so that's the base finish now, apart from its powder coating, but I'm going to hold it over for another episode. I'm going to do all the powder coating in one hit, and I'll give you a good look at that. But I think we're pretty much done on the machined parts for the base and the end caps. So I think I'll wind this episode up here now. We all get an early mark. Well, here are the parts we did today. I've cleaned them up and I've removed the die cam off this casting here. And these are pretty much finished now. We don't need to touch them again until we do the powder coating. And here's one of the end caps screwed to the timber frame. I've temporarily fitted that stainless steel mesh into that opening there, but I'll give you a better look at how that was cut later. And these are the copper T-fittings that are going to be used to suspend this timber frame over the cast aluminium base. And that's what we're going to be doing in the next episode. So let me show you the drawings of all the bits we're going to do, and we'll hop into that in the next episode. These are the 2D drawings for some of the parts I'll be doing in the next episode. So these are the copper arms that need to be bent up, and they will fit into those T-fittings that I've already shown you. We also need this sort of a donut shape here, and it's going to screw onto the end of this casting by this thread in the center here. And we'll also need this decorative screw here. All of these parts will be made from brass, and if we get time we'll do these flanges as well. They're just decorative. They're meant to sort of give that sense of a boiler room with steam pipes and, you know, bolt together flanges and so on. So we'll see how we go. We might get that done in the next episode. But some more parts come, or more machining. Going to be a load of fun. Well, that's it guys. Thanks for joining me on today's episode. Catch up again next time. Should only be about 2 or 3 weeks. We'll be full on machining and making parts for the clock. And I've got a surprise feature that's undergoing development right now. And if it pans out, it's going to blow your mind. I guarantee it. So hopefully I can unveil that right toward the end of the build. But for now, it's Prozo signing out. Thanks for watching. I'll catch you on the next video.